Confidence intervals for proportions. The confidence interval for a proportion is given by the formula p hat plus or minus z times the square root of p hat times the quantity 1 minus p hat over n, where p hat is equal to x divided by n. X represents the number of success, and n is the sample size. We have two conditions. The first condition that we need is n p hat times the quantity 1 minus p hat must be greater than or equal to 10. The second condition is the samples have to be independent, which means one outcome cannot influence the outcome of another. This means we need to reasonably assume that the population size n is at least 20 times that of the sample size. Before we start any problem, we have to check condition 1 and condition 2. Example 1. The drug Lipitor is meant to lower cholesterol levels. In a clinical trial of 163 patients who received 10 milligram doses of Lipitor daily, 47 reported a headache as a side effect. Construct a 90% confidence interval for the population proportion of Lipitor users who will report a headache as a side effect. We'll have to check the first condition, which is to make sure that n p hat times the quantity 1 minus p hat is greater than or equal to 10. So we'll find p hat first. P hat is x divided by n, and in this case x is the number of successes, 47, and n is the 863 patients that we tested. So x is 47 divided by 863. So p hat is about 0.054. I know n is 863, and now I also know p hat, so we can plug in everything into this formula. 863 times 0.054 times the quantity 1 minus 0.054, and that is equal to 44.1, which is clearly greater than or equal to 10, so condition 1 is met. Condition 2, we have to make sure the sample size is less than 5% of the population size. So we're going to assume this by saying the population size is at least 17,260 individuals. Where did I get this number, 17,260? I took the sample size, 863. I multiply it by 20, and we get that 17,260 that we were looking for. So for the second condition, all you have to do is write the sentence, the sample is less than 5% of the population size. It is reasonable to assume that the population size is at least 17,260 individuals. The second condition is always assumed because if it wasn't true, then we would not be able to do the problem. P hat is known to be 0.054, and we know that z can be obtained from our t-table. We need to use the formula 1 minus the level of confidence divided by 2. In our case, we have a 90% level of confidence, so I'll take 1 minus 0.90 divided by 2, and this yields 0.05. This is the column that I will use, 0.05. Since we're looking for a value of z, we'll go to the very last row and the z value we need is 1.645. Z is 1.645. The sample size is 863. And now we can plug everything into the formula to find our confidence interval. P hat plus or minus z times the square root p hat times the quantity 1 minus p hat divided by n. P hat was 0.054 plus or minus 1.645 for z times the square root of p hat, which is 0.054 times the quantity 1 minus 0.054, and we're going to divide that by the sample size 863. Simplify the right side of the equation first. So I have 0.054 plus or minus 0.0127. I have to perform the subtraction between the numbers, and then we'll do the addition, and this gives us a confidence interval of 0.0413, comma 0.0667. We can conclude that we are 90% confident that the proportion of Lipitor patients that will report a headache as a side effect is between 0.0413 and 0.0667. A Harris interactive poll conducted in the United States between January 15th and 22nd, 2008 found that 322 of 2,302 adults aged 18 or older have at least one tattoo. Construct a 95% confidence interval for the proportion of adults with at least one tattoo. Again, we have to check the two conditions, so we make sure that n_p hat times the quantity 1 minus p hat is greater than or equal to 10. P hat is equal to the number of successes divided by the sample size. We have 322 divided by 2,302, and this gives me a number of 0.140. So p hat is 0.140. And then I can finally check the condition n_p hat times the quantity 1 minus p hat. Let's check the condition now. The sample size is 2,302. We're going to multiply that with p hat 0.140 times the quantity 1 minus 0.140. This yields 277.2, and that's clearly greater than or equal to 10, so the first condition is met. Now for the second condition, all we have to do is state the same sentence over again. The sample size is less than 5% of the population size. It is reasonable to assume the population size of adults in the United States is at least, we're going to take 20 and multiply that by the sample size of 2,302, and we get 46,040. That's where this number comes from. It is reasonable to assume that the population size of adults in the United States is at least 46,040. All the conditions are met. Now we can do the problem. From before, we calculated that p hat was 0.140. The sample size is 2,302 individuals. and Z can be found using our t-table. To find the correct value of Z, we take the level of confidence and subtract it from 1. 1.95 divided by 2. This is going to tell me the column is 0.025. I look at the column 0.025. Since we're looking for a value of Z, we'll go all the way to the bottom, the last row, and our Z value is 1.960. Z is equal to 1.96. We'll plug in the values into the formula. 0.140 plus or minus 1.96 times the square root of 0.140 times the quantity 1 minus 0.140, and divide that by the sample size 2,302. We'll simplify the right side of the plus or minus, and that simplifies to 0.0142, and our confidence interval is going to be 0.1258, comma 0.1542. We can conclude that we are 95% confident that the percentage of adults that have at least one tattoo is between 12.58% and 15.42%.